Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us talk about, again, of bridge engineering, but this time, let's give you the principles about analyzing the bridge itself, the design of the bridge. Okay, so let's start with the analysis methods. What are the analysis methods that are being used today? These are current information. These are the these are the tools and methods that are being used by real engineers in real life. Okay, so we have what? Line girder analysis using single dimension. If we have 2D or 3D, we can use the refined analysis method. Okay, these are the methods. So we will give you one method only in this course because we cannot provide so many types of methods. So in this video, we'll just explain to you the different types of analysis methods. Okay. The next type of analysis method is what we call, again, line girder analysis. What do you mean by line girder analysis? Either it is one dimension or 2D or 3D. It considers girder only. Okay, so girder meaning beam analysis. Okay, so we are going to use the beam. So using your theory structure, you can analyze the bridge as a single dimension, 1D. Okay, no recognition of system behavior, appropriate for final design of simple bridges, appropriate for preliminary design and validation of complex bridges with caveats. Okay, so meaning caution and warning. So caution with proper caution. Okay, so if you are using the 2D or 3D, it is more complex. Okay, but still you can use what you learned in theory structure. Okay. Next, refined analysis. So we are using 2D or 3D. That is what we call refined analysis. Okay. So line analysis, that is single or one dimension. Refined analysis, 2D grid analysis, or plate and eccentric beam analysis. 3D, we are going to implement PEM. So that is finite element method analysis. That is what we mean by PEM, meaning F, finite, E, element, method, finite element method analysis. Okay. So again, what do we mean by 2D grid analysis? So it means girders modeled as line element. Again, line elements. Diaphragms modeled as line elements again. So diaphragms and girders, diaphragm, and deck model in strips as line elements. Okay, so they are modeled as strip and become a line. So that is what we mean by grid. So still a grid, but we can call this a split. So because this is what. So variant of 2D grid analysis. Okay? Still a grid, but it is a plate type. So we have what? The deck model with plate or shell elements. Okay. Plate or shell elements. This is a plate. 1 plate, 2 plates, 3 plates, and so on. So plates, okay? Or shell. Okay. So instead of what? Line being beam and line being diaphragm. So we have what? Plate. Okay. And then we have what? Here. 3D, almost a 3D. Okay. So 2D, still a 2D, but what about 3D? So if 3D, we are going to use PEM. So it is an analysis method which separately or at the same time simultaneously analyzes flanges, webs, diaphragms, bracing, okay, and deck. Okay, at the same time. Okay, we can do it at the same time. So plans meaning plans of beam or plate element. Okay, meaning plate elements, that is that are vertical. Diaphragms, those are bracings. Truss or plate elements. So those are what we mean by diaphragms. Okay. So deck, those are solid or plate elements that